So let's have a look at a question just determining standard deviation. So we'll have a look at, let's have a look at 2b here as shown on your screen. So I've already got our calculator set up here to the side. We're going to use our calculators to do standard deviation questions here. So let's have a look at this sample of data here. So we're having a look at 3b. We're going to go in and enter our data like we normally would in our statistics. So let's just quickly go back to the menu. We go to 2 statistics, right, and then we enter our data. So 3, 555, 6, 7, 8, 10, 11, and 12 into our list 1. So we'll do that now. So 3, 5, 5, 5, 6, 7, 7, 8, 10, 11, 11, and 12. All right, so you can see there that our number 12 was actually our 12th piece of data there. So this is really easy now. All you need to do, let's just hit exit there, so it takes us back to our, exit. Let's just go back to our set of functions, or our set of tools along the bottom. Here we've got graph, calc, test. You know, you can go here and delete all your data here. So we'll go back around to the front and we will go calculate. All right, so we're going to calculate using F2, and we have one variable analysis here. All right, so we're just talking about single pieces of data. If we hit F1 there, we're going to get all of that information that we're used to getting when we were doing our measures of central tendency and measures of spread earlier in the term. We spoke about the mean being 7.5. We spoke about the number of pieces of data being 12. We scroll down a bit. You know, our minimum is 3, our Q1's 5, our median 7, our Q3 is 10.5. Our max is 12. We've got a mode is 5, and there's only one mode because 5 occurred 3 times more than any other piece of data. So if I quickly just scroll back up to the top, you will notice that there are two other, there are two or three odd-looking bits of information here, and what we're doing is we're looking at, there we go, our sigma x. This piece of information here being 2.78. So that is our standard deviation for this set of data in 2b. So like I said, within one standard deviation, either side of the mean. So if we went 7.5 and we added 2.78 to it, and if we went 7.5 and took 2.78 from it, we would have approximately 68% of all of the data that we've got in this question lie within that one standard deviation. If we went 2 standard deviations, again, if we went 3 standard deviations, we'd end up with almost 100% of that data within inside the 3 standard deviations. So standard deviation is a measure of spread. It actually gives us some information about how much data actually lies, close to or away from the actual mean.